Hello, ladies and gentlemen of geometry. People of geometry, rather. I hope the first two sections went well for you. I know that there's a lot of details that you need to keep straight, and a lot of pieces in there that can be tricky, and there's some subtle things you need to be aware of. But I hope that you're able to keep all that straight. So, for 4.3, we start looking at rectangles, and everyone thinks they know what a rectangle is, or could at least draw one. Most people would just draw a rectangle similar to something I just drew there. But if you ask someone to define a rectangle, they often are at a loss for words. They're like, well, I don't know how to describe it. There's four sides, and after that, they kind of get tongue-tied. They're not sure what to say. So when we talk about rectangles, there's a couple things that we need to be aware of. The easiest one is that, yes, it's a quadrilateral. Okay, it's got four sides. Beyond that, it is also a parallelogram. So all those properties that we talked about in 4.2, all of those properties hold true. Okay, those hold true in a rectangle. There's also a couple other details that we need to talk about with rectangles that make them very, very specific. So let's take a look here. So a rectangle is a parallelogram with four right angles. Okay, so it's a very specific type of parallelogram where all the angles are right. Okay, so four 90-degree angles. So just reviewing the properties of parallelogram, opposite sides are going to be parallel and congruent. Opposite angles are going to be congruent. I'm using the symbols here. Consecutive angles are going to be supplementary. Remember, that means they add up to 180 degrees. And the diagonals bisect each other. Okay, so all of that is true. All of that holds true in a parallelogram, okay, and it holds true in a rectangle. But the only addition is that it's got four right angles, okay? So if you consider all of the parallelograms, okay, all the parallelograms, kind of a smaller subset will be rectangles, okay? So it's saying parallelograms, they have all these properties. Rectangles still have all those properties, plus four right angles. Okay, so it's a parallelogram, but it's a very specific parallelogram. And the way that you distinguish it is that it has four right angles. Okay, so now, as a result of that, so kind of as a direct result of having four right angles, remember in parallelograms, diagonals bisect. And in rectangles, the diagonals also end up being congruent. Okay, they end up being congruent. So what's clever here is this. In a rectangle, and this works only in a rectangle, all four of these end up being congruent. Yeah. All four of these, they bisect, so they cut each other in half, but they're congruent. So if you have two things that are of equal measure and you cut them both in half, now you have four things that are all equal measure. So what you might notice is that you've created four isosceles triangles. Yeah. Just something, just kind of a natural consequence of four right angles, that the diagonals are congruent. Well, they bisect. So I create four isosceles triangles there. All right, so now let's take a look. So I have a rectangular park, and I have two walking paths as shown. So PS is 180 meters. PR is gonna be 200 meters. Figure out QT. So they want you to figure out that one. Okay. Well, and if it's a rectangle, that means that my diagonals are equal. So if PR is 200, then QS is also going to be 200. And then realize that they cut each other in half. So that's going to be 100 meters. That's going to be 100. This is going to be 100. And this is going to be 100. So I'm going to say 100 meters. Because you're automatically going to cut that in half. So now, if we look at B, they tell me that TS is 120. So we're changing gears here. We're changing measurements. So we're going to change some things here. Okay, so we're changing measurements. So we'll look here and say, okay, TS, this length right here, we're going to say is 120. They want to figure out how big is PR. How long is that one? Well, if this is only half, okay, this is bisected. Well, then this is also going to be 120. This is going to be 120 as well. So I'm just going to go 120 plus 120 and get 240 meters. That's kind of it. That's kind of all you're doing right there. Okay. Now let's take a look here. All right. So now let's look. Okay, so they tell us it's a rectangle, which is nice because that tells us a lot of things. Okay, KJL, this is going to be 2x plus 4. And JLK, this is going to be 7x plus 5. And they want you to figure out x. Okay, so let's kind of take part of this and look and see what I got. Okay, so JK, KL. So if I just take JKL, 2x plus 4, 7x plus 5. So if I look at just this triangle, well, K is in the corner, so that's going to be 90. So let's consider, I've got a triangle here, right? So triangles have to add up to 180. Well, I know that one's 90, so then I just have 2x plus 4 plus 7x plus 5 plus 90. So let's put that together. So I end up with 9x plus 99 equals 180. So 9x, 180 minus 99, okay, should just be 81, right? 180 minus 99 is just 81. A little division, x is going to equal 9. There's your answer. Okay, so all that recognizing that I've got a triangle in this thing, and that's kind of how I'm working. Okay. So if we look, if we're going to figure out if this is a if this shape PQRS is a we're going to figure out if this is a square or a rectangle rather. Remember, opposite sides must be parallel. And diagonals must be congruent. Okay, so we're going to use, well, an opposite side, maybe not parallel. We're going to use the distance formula a lot. So opposite sides must be congruent, and diagonals must be congruent. So if I just kind of sketch something very, very quickly here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5. So negative 5, 3, this would be P. Q is going to be at 1, negative 1. R is going to be at negative 1, negative 4. S is going to be at negative 7, 0. Okay, so I know my graph isn't very clean. So this has a chance to be a rectangle. This has a chance to be a rectangle. Okay, so I need to see, do these two, are those two equal? Are these two equal? Then are the diagonals equal? Because the diagonals being equal is what tells me this is a rectangle. Just having the sides equal, that tells me it's a parallelogram. Okay, so way back in Unit 1, I said, hey, you're going to have to get fast and you're going to have to get good with the distance formula. Okay, you're going to have to get good and fast with both of those. So if we look at PQ, okay, so distance formula is just this. For those of you that I forgot, so x2 minus x1 squared plus y2 minus y1 squared. Add that together, take the square root. So for PQ, so I would take 1 minus a negative 5 squared plus negative 1 minus 3 squared. Okay, so 1 minus negative 5, negative 1 minus 3, so that would be 6 squared plus negative 4 squared. So that would be 36 plus 16. So that would be square root of 52. Okay, and I'll leave it like that, square root of 52. So now I need RS. So RS is going to be, let's see, so I'd go negative 7 minus a negative 1 squared. And then I'll go 0 minus a negative 4 squared. So that would be negative 7 minus, so that'd be negative 6 squared. So that'd be 4 squared. So let's see, that RS, PQ, let's see. Somehow I've got RS, PQ. So negative 7 minus negative 1, 0 minus negative 4. So I end up with 36 and 16 again, and square root of 52. So this tells me that these two are equal to each other? Or no, PQ and RS. Okay, that's what I want. That's what I want, PQ and RS. Okay, sorry about that. Got a little turned around, a little confused. Okay, so let's give myself a little bit of room here. Let's give myself a little bit of room. Okay, so we know that those two are good. Okay, so now let's look at our PS. So PS we'll do up here, so since we just gave ourselves some room. So PS, and I'll pick up the pace a little bit. So negative 7 minus negative 5 squared, plus 0 minus 3 squared. So just doing some number crunching here. Just doing some calculator mashing. So that should be 4. That should be 9. That's just going to be square root of 13. So that's that one. QR, which I'll do over here. QR, I'll kind of jam it in. I'm sorry about that. QR, I'm going to go negative 1 minus 1 squared plus negative 4 minus negative 1 squared. So that will be, so just doing that, that's going to be 4. That's going to be 9. So that's going to be square root of 13 as well. Okay, so this thing, boom, 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 it's definitely a parallelogram. It's definitely a parallelogram. Okay, so now to go one step further, I got to show the diagonals are congruent. And I appreciate you hanging with me. I know this is a tough problem. So we'll go quickly. So I need to find PR. So I'm going to go negative 1 minus negative 5 squared plus negative 4 minus 3 squared. So that will be 4 squared plus negative 7 squared. So that'll be 16 plus 49. So that'll just be square root of 65. And notice I'm leaving all these in square roots just because it's way easier to notice what's congruent to each other if I do it that way. Okay, so finally QS, so let's see, that'd be negative 7 minus 1 squared, and then 0 minus negative 1 squared. So that will be negative 7 minus 1. Okay, so negative 7 minus 1, that'd be negative 8 squared plus 1 squared. So that would be 64 plus 1. So that would be square root of 65. So yeah, this is a rectangle. This is a rectangle. Is this a very, very long way to do this one? Absolutely. But that's what I have to do. And I have to use this distance formula extensively. So you show I've got two sets of congruent sides and a set of congruent diagonals, and that tells me everything I need to know. Whew, tough problem there, tough problem. Okay, now they tell me that I have a rectangle. XW is 3, WZ is 4. Figure out XZ. Okay, and that is C. Okay, so I've got a right triangle where this is 3, this is 4. You want to figure out C. So that is square root. So C equals 5, which means this whole diagonal is 5. So the WY then has to match. So that's going to also be 5. Okay, way shorter than the last one that took forever. Okay, so this one's just bringing back Pythagorean theorem. That's all I was doing. And then recognizing, okay, this is a rectangle. That means my diagonals are congruent. Okay, that's it. So off you go. Go work very, very hard and come to me with questions.